Okay, today, this new chapter of the Data Science Incubator, hopefully we'll be wrapping up what we have been discussing about ways to improve the way we manage data and use it. And not to say that, we're going to discuss today is, the last word or anything. It's just, I think we got to a point where we have enough tools in our head to kind of think about, we already know a few resources that we can use, and this meetup will try to kind of wrap them up. But then in terms of a decision about, how we should go about our own work, that's something that is a little open. And, Alex did a very good summary of what's his view, and I think it's a very good one. So we may keep the discussion kind of happening at the background. But I think today is a good place to kind of stop here for a while, let it see how people adopt these tools or not, or, bring problems that, we might address and help, as Alex said, reduce the friction in adoption. And then move on to something else, because I think we are getting a little bored about this topic, and we need some time to try things out before we decide, what we actually do. So, well, with that, I think some people have already signed in. The idea today is to basically reflect at a very high level everything we've been discussing so far, and also making it concrete at the same time, and giving some specific recommendations or looking at specific tools. So the objective also, I want to reflect on the last meetup. I really liked that thanks to you giving written feedback, I was able to reflect on that and write notes. So if you want to go, if you ask a question there, it's very likely answered in that doc. So I invite you to go back to that doc of the last meetup when you want. And also expose some things that I didn't explain clearly enough probably, so I would like to kind of revisit them today. So one of the main objectives today is to clarify what is the cache. That's something that it was very unclear to me actually as well, until I decided to start teaching this. So I learned through teaching, but I think it's a very easy thing to not fully grasp, because it's not very common in our workflows yet. Second is to try and understand how a cache system might be a better alternative to the way we already access and store data in Dropbox. And then third, basically answer the same questions that I asked last week. The reason why I'm asking them probably today again is because I think that, from your feedback last time, I realized that we weren't very able to answer those questions. There were a lot of things I didn't clarify, like, for example, what is a cache? So I think that today, hopefully, we'll be more equipped to answer those things. So the first thing I want to do is just show you this little definition I found on the internet. I think it's quite eloquent, so I'm going to just read it about what a cache is. So in computing, a cache is either a hardware or a software component that stores data so that future requests for that data can be served faster. The data stored in the cache might be the result of an earlier computation or a copy of data stored elsewhere. So with this in mind, for example, a cache could be an exact copy of something that lives on data store, and we create just a copy of it closer to our analysis scripts, analysis code, so that when we want to access that data, we don't have to, go through the internet, for example, to get it, and instead we get it directly from our computer. So that's one way to use a cache. Another way to use a cache could be when you have done some computation, you already have this, original source of data, raw source of data, but then you compute something that is expensive and time consuming. And, one way to get that result again is to recompute the thing, but of course you have to wait all that time again. And another alternative is just to get a copy from your cache. So a cache is almost a synonym of, it's a very special way of kind of saving data. It's just one way of saving data somewhere that you can access it quickly. And sometimes you don't even need to know where that cache is, which is kind of difficult for us to understand, because usually when we save a file and when we read from a file, we need to know where that file lives. So we need to give a path to a function like read CSV, for example. But with cache systems, they are so well fine-tuned that sometimes you don't even need to know where things go. But it's good to know in case you need to do something more advanced. So that's the little definition of what a cache is. And I'm going to, in a moment, do a little formative assessment to see if we all are on the same page about what that is. But before, I wanted to revisit another, like the highest level discussion that we have had about managing data, and it's this meetup that was run by CJ, and I did a little introduction, a 5-minute introduction. It's called The Flow of Data, my introduction. And it all starts with, how this relates to your work. So basically, as an analyst, this image here tries to capture what are the tasks that you usually do. And this comes from the tidyverse kind of model. Basically, you import data. Sometimes you have to reshape your data in some way. That's called tidy. Then you enter a loop where you transform your data, for example, to normalize your data or something like that. Then you may create a model. Then you may visualize it in some way. And you may do that several times until you're ready to communicate your results. So if you don't use any, you may go in this figure from end to end, from import to communicate, with a single script that reads raw data and does the whole thing in the script and spits your result, right? But in more complex data analysis, that's not the case. In more complex data analysis, you may need to, actually this view we can skip. In more complex analysis, you may need to save intermediate results because they are expensive to compute. So at any step in your workflow, you may need to store a modified version of the data or a copy of the original data that is closer to you. And that's exactly what a cache does in a very sophisticated way. So you have been doing this already just manually by saving a file to Dropbox or to your local computer, and now the idea of using a better tuned system that is called like a cache system is just doing the same thing in a fancier way with some nice features. That's all it is. So basically, all that you want is to have that data accessible to you so that you can retrieve it. And you can continue your loop without having to recompute very long things. So one way in which we have been doing this is with Dropbox. So one place where you can store things is in Dropbox, and that's totally fine. The only problem with Dropbox in terms of the discussion we're having is that it doesn't automatically create, when you read a file from Dropbox, for example, it doesn't automatically create like a cache that is kind of smart that would read from your cache if it's not available online, So that feature is not ready in Dropbox. We could build it, but instead of build it, we have been thinking that there are better tools that already have that kind of feature. And again, basically the idea that, let me go back one step. So the data, you may want to have a remote copy of the data, maybe in the database, and a local copy of the database of the data. And Dropbox does that, so there is an online version of Dropbox where you can store data, and also a local version. But Dropbox itself doesn't provide you any tool to say, well, if I'm offline, or if I'm trying to compute my thing offline, then get it from my local Dropbox. But if I am online, or if my local Dropbox is not available, then read it from the remote source. So that kind of where things come from is not so well featured because it's not meant to do that. Pins is one alternative for that. That Pins will know of where your data lives remotely, and it will automatically create a local cache. So that's why I presented it, but it's certainly not the only way to do things. It's just one way that seems to be working well, and also works well with Azure. That could be our kind of remote side of the equation. So we could store data in Azure. we can bring it to our local computer quickly with pins, and then pins will decide if it's going to get it from Azure or from the local cache, depending on where it is available, kind of. And that's about it. That's the high level picture that we painted last time. So with this, I hope to have clarified a little bit what a cache is, but I would like to run a little assessment because it's great feedback for me. I want to know if I explain more, then maybe I'm boring you because you already know everything that you already know, or if I skip it, maybe I'm not explaining something that is still unclear. So let's do a little assessment now. So there is 3 items here, and for each of these 3, I will ask one each time and ask you to click yes or no. And the questions relate to is the following. So when a data set is available in a cache, I prefer to get it from the cache because that's the background. So the first one I'm asking you is, when a data set is available in a cache, I prefer to get it from the data, to get that data from the cache because reading data from the local cache is faster than recomputing a result. Is that, could you click yes or no? Go ahead and do that on the participants tab. So in Zoom, there is hopefully people have a yes or no thing. So is one of the reasons why you would want to read from a cache the fact that, or is it true that reading data from local cache is faster than recomputing a result? Okay, I see most yeses, so that's great. I'm gonna put the thing here. Hopefully you see it. Yes. Okay, I agree. Reading data from a local cache is faster in general than recomputing the thing. So that may be one of the reasons why you prefer to use a formal cache system. So let's go to the second one. I'm going to clear all here. Let's go to the second one. So again, when a dataset is available in a cache, I prefer to get it from the cache because, number 2, reading data from a local cache is faster than reading from the remote data source. Say yes or no. Okay. I see a no there, and that's something very interesting because it might be, so my natural answer, actually I didn't think of a no, but I now reflect on that. My natural answer would be that it is always faster than reading from a cache, but we also learned from CJ last time that you may query a database lazily, meaning that you don't compute anything really, and you may access just like a view of the first few rows of a data set that exists on the database. But that seems like to be a special case, and probably at the end I would like to hear the explanation for that no, if someone has a different one. But in general, I would be happy with you thinking that the answer for that is yes. And then the last one. So again, when the data is available in a cache, I prefer to get it from the cache because reading the data from the local cache is slower than reading data from the remote source, but I can work offline. So let me reset, actually, sorry, let's go again. Let me reset it and let's do the assessment again. So is this a reason? So reading the data from the local cache is slower than reading from the remote data source, but the good thing is that I can work offline. And I see mostly no's. Okay, here is the thing. Assuming that 2 was yes, which I think now that it's not always yes, but I'm happy with taking 2 as a yes. If we assume that 2 is yes, then okay, we agree that reading from a local cache is faster than reading from the remote source. So that would make 3 false. And then the second part is kind of tricky. Yes, it's true that with your local cache, you can work offline, because even if the data in the remote source is no longer available, you can still have access to the local cache, which is the equivalent to, say, having Dropbox desktop in your computer in case you cannot access Dropbox online, right? So, okay, I think that we are, although the mental model of what a cache is might be not super strong, I think we kind of know in which ways we can use it. I have a question from Alex. Go ahead, Alex.
Really just more of a comment that these three statements are all true if you are looking at the exact same data set, either in the local cache or in a remote area. But if your goal is to acquire data and then do some computation on it or some transformation of it, so as an example, get my data set, do some filtering, do some calculations and summary statistics on it, right?
Mm-hmm.
It is entirely possible that if I have a local cache of like the master data full table that we use all the time,
Mm-hmm.
right? That is going to, one, be a pretty significant cache on my local machine. And it's depending on what I am doing, getting that to do its calculations while it's still in the Postgres database might be faster than having R do those same calculations on my local machine.
Great. Yeah. Is that the reason? Was the no for two?
I said yes there, but
okay.
I think the important take home from that whole idea is having a cache of the original data set is not as useful as having the cache of the computed results.
Perfect. That's great. I think that that's a very very important point, and encouraging towards the better at trying to understand what benefits we can get from the cache, saving intermediate computations, because we do run very long running computations. So I have a couple of more exercises here, but given that that I'm hoping this to be like the wrap up meeting for the where we use and manage data, I think I would prefer to have an open discussion now, while also encouraging to, once we reflect, to then put also your thoughts in writing in this talk, maybe later. I don't want to kind of fill the whole time and not give you the chance to ask questions or say something now kind of aloud. So let me explain what I'm skipping. What I'm skipping here is a file that is available in the same RStudio project that you used last time, but this file was added later. So if you want to see it, you will need to create a new copy of that project. Basically, what it is an explanation of how a database manager might create a number of flat files on Azure that you may get for your analysis. It's just a toy example, and it shows how a database manager might choose. It's just my imagination, how they might choose to create a timestamped series of the same files, like different versions of the same file, and how you may be able to access, for example, the latest version of that. So that's my imagination of one workflow that we could potentially develop, but I haven't consulted that with the database manager. So it's just my imagination. So if you want, go there and have a look later. But for now, what I really would like to do is basically with this thought in mind, comparing the approach that we already have, Dropbox, versus this proposition of a new approach, Azure plus Beans. for you to now, say aloud what are the advantages that you see and the disadvantages, and if you think that this proposed framework might not work, if you can try share some ideas about how I or the database management could build something that might increase the chances that you would adopt some alternative that is better than what we have. And maybe that might be just tweaking the Dropbox framework so that it does something similar to what Prince does. So with that, I'll shut up and open the room for comments and questions.
So I have some comments about caching and like a caution to propose. And it's certainly not a criticism, because normally I advocate for caching as well because it has some big advantages. But there are also places where it doesn't. So in one case, imagine that you have like a 5 terabyte data file that lives on a server somewhere. And maybe you, in your analysis, you need to download that data and you need to filter it sometimes. Maybe there's an indicator that you use to filter that, which would split it into thirds. So then whichever one you choose, you would end up with maybe 1.5 terabytes of memory for that. So if you use the caching system in this, you would end up, or would likely end up, with a local cache of a 5 terabyte file plus 3 1.5 terabyte files, which ends up being like twice the size of the original size. And you kind of then lose the advantage of, like, normally you might be storing this file that large somewhere else because that is, you have the physical resources to do that well, where you might not have that locally. So of course that's a very extreme example, but I think extreme examples kind of point out like the constraints of something. So the point that I'm trying to make is that in some cases caching doesn't make sense if you end up caching a lot of stuff and you end up caching more than what's even stored on the server. So how that's relevant to 2DI, I could imagine that with a lot of people running the packed analysis or whatever it is, and caching lots of intermediary filtered versions of the data, you could end up with like an enormous amount, a very, very large cache that has massive amounts of duplication in it, which might eventually reach some point where it's that there has some consequences to that. I don't know if that's it's hard for me to say right off the bat if that's something likely to happen, but I think that's something to consider.
Okay. Yeah, I see that happening already in Dropbox, right? Because Dropbox is our kind of low-tech cache release where we store data and we get it from, and sometimes we create copies of things that are still there. And because a lot of people have Dropbox desktop, basically what they are doing is exactly what you're saying. They have like a gigantic folder that's living there in their computers. As I would like to hear from someone else, your questions. There is also the doc space for your questions and feedback. So if you don't have the opportunity to speak now, whenever you can, please go ahead and put them there. But let's use this the rest of the time to hear from you. Go ahead. Who else would like to ask a question or make a comment? Especially focus on the advantages that this framework might bring, or the limitations that you would like us to help you solve.
I just have a question that might be slightly stupid, I don't know. So basically, if I create a cache and I have all the relevant files in there, and then I restart my computer, restart R, is the pins package making sure that it's really locally stored on the computer, or is it just putting it in the memory and then I can't assess it if I restart it? And so then it doesn't help me to anticipate that I need an offline version of the file. I also need to keep my computer running, or at least like don't restart it.
Yeah, that's an excellent question, Klaus, because of course, you would fear using pins if you think the data won't be available there. So yes, the answer is the cache is actually just a folder living in your computer. And you can access it regardless of the session. So you can open a new session tomorrow and it's going to be there. So I'm going to scroll down here. this, what I'm showing you here is something that comes from last session. And I think that this image that you see here kind of more or less shows that the cache is no more and no less than just a folder in a computer. In this case, you won't recognize this path as something very natural to you, because you would more normally see something like C, your name, and something like that as a local folder. But this is a local folder on the server, right? So in this case, last week we were working on RStudio server on the cloud, so RStudio Cloud. So what's local for the server is this thing, right? The home of that server. Then there is this folder, and then there is a folder called .cache. It starts with a dot, which is just hides that folder from a normal view of your file system. And then there is another folder called pins, and inside there is a bunch of data sets. So yes, it is no different than Dropbox in that way, right? It's just a folder living in your computer somewhere.
Okay, and then the follow-up question basically is, how easy is it to, because currently what I do is I smart sync and unsync a lot of stuff always to make sure that I'm not messing up my computer hard drive. And like, how easy is it to remove certain bits and pieces? So for example, I know now I just need the latest data store release. I don't need like the flag from last project. How easy is it to change that?
Yeah, that's true. I encourage you to go to the doc of last week. Someone asked that question, and I hope that a little screenshot that I pasted there shows one way in which you could filter data sets by age and size. So basically, if you want to, and with this we'll have to end, but let me show you here, going down.
Yeah, I mean, like, I can also look at it, but I think what I think is then crucial that we have, that it's easy for people to get this knowledge. So how to manage the cache.
The cache, yeah.
Where to find it. And I mean, if someone is coming new to the organization, this should be directly present, very easily accessible, like, yeah.
Perfect. Yeah, actually, that's a good point, because we could build tools to basically what I'm showing here is how you would do it kind of by hand to see what's in the cache, arrange it by size and by age, and then decide as a human what to keep and what to remove. But maybe we could build tools that are a shortcut for this, and you can just say, remove everything that I haven't used in 6 months or something, and it just happens, right? So, okay, to wrap up, because it's actually already too late. Again, I really encourage you to do what you did last time in the document of today. Write there your questions that you didn't have time to ask now. Write there your feedback if you have anything. And if there is, in particular, if there is anything that is still unclear, so that we will touch on later on. Next meetup, hopefully, will be a different topic, so we refresh and we'll let all this sit and see how it works. Hopefully, people will start trying things out. So with that, I have to say goodbye, because we are already stealing 2 minutes from Taylor's time. Sorry for that.
Thanks, Mauro.
Bye, thank you.